Thank you so much. Thank you so much for having me. It's a real pleasure, and yeah, thanks for the nice introduction. So this is really work in progress, and lots of it has to be filled in. I'm grateful for any comments you might have. I'll try to run through the slides fairly quickly. I think some of this might not really be news, and if once you get the hang of it, it will be kind of repetitive and same old in some sense. I hope we get to the point where you have that feeling. All right, so bilateralist truthmaker semantics for ST and related logics. What I want to do today is first some introduction and then two kinds of bilateralism. So truthmaker bilateralism and what I call normative bilateralism. And then I want to bring them together, which I call stereoscopic bilateralism with a hint to Sellers. Then I want to go through a couple of applications, as it were, what you can do with this kind of stuff. All right, introduction. So let's start with Aristotle. Aristotle famously, as Jukashevitz noted, has three different principles of non-contradiction. One is the logical, and it's pretty general. So for example, in metaphysics gamma, he tells us that opposite assertions cannot be true at the same time. And if we let consequence be the single turnstile, you might try to write this as A and not A are incoherent, or A and not A turnstile. Now, he has two further principles, and they differ more radically. And one is usually called the metaphysical principle of non-contradiction, and the other is usually called the psychological principle of non-contradiction. And the metaphysical principle runs as follows. It is impossible for the same thing to belong and not to belong at the same time to the same thing in the same respect. And then he has a bunch of caveats about respects, what same respects mean. And I mean, I'm not into Aristotle exegesis, so this is not supposed to be a historical claim, but you might think that this could mean something like that A and not A is incoherent, means something like it's impossible for A and not A both to correspond to the facts. And then there's a psychological principle of non-contradiction, which runs, it's impossible to hold or suppose the same thing to be and not to be. And you might think that that could be rendered as saying what it means for A and not A to be incoherent is that, well, it's just incoherent, or you shouldn't do it. If you read this in as a normative can, right? You shouldn't hold A and not A. My claim is that I think it pays real dividends if you think of logic in general and contradictoriness or inconsistency in particular as being systematically ambiguous between these two things, between the normative, as it were, and the metaphysical. So let me tell you about the goals for today. So one way to formulate the goal I have is to convince you that what I call normative bilateralism, by which I mean the kind of position that, for example, Greg Restall holds or Dave Ripley, people like that, and truthmaker theory of the sort that Fine advocates are respectively the normative and metaphysical side of the same coin, a lot like the metaphysical and normative principle of non-contradiction in Aristotle. Another way of putting that could be to say, normative bilateralism tells us what norms we must have in order for our sentences to have the contents that Fine specifies sentences to have in his truthmaker semantics. One way in which I will try to cash this out is to give semantics for some substructural logics, and I hope that that semantics is better than standard semantics. It's better, I hope, than three-valued semantics. So for ST and TS and LP and K3, of course, we all know the three-valued semantics. And I think this one is better because it's more flexible. And I also think it's better than standard residuated lattice semantics for substructural logic, because for these semantics, I usually don't know what they really mean. I don't know what their representational import is, as it were, how they represent the world. And that should be, I hope it's pretty clear how the semantics I'm going to suggest does that, namely truthmaker semantics, right? It's no mystery. And then if we can do that, I hope that we can show how ideas transfer freely, as it were, between truthmaker theory and normative bilateralism. So if you have an idea in one of these fields, you can transfer to the other and then the other way around. So building a bridge. And in particular, so as examples, but these are mere examples, I want to say that paradox solutions travel from the TSST-ish side to the truthmaker side, and then ideas about, for example, factual equivalence or partial content travel from the truthmaker side to the ST-ish, TS-ish side of things. All right, so let's run quickly through the two kinds of bilateralism. So we start with the truthmaker bilateralism, and then we get to the normative bilateralism. Truthmaker bilateralism. So according to Phi, there are exact truth makers. Those are states of the world, states understood very liberally. And a truth maker for a sentence makes that sentence true and is wholly relevant for that sentence. And then if we want to capture that in a little bit of formal way, you can say you have a modalized state space, and a modalized state space is a triple of a set of states or states of affairs. These are truth makers. And then you have a subset of those. Those are the possible states. And then you have a partial order on them with what is guaranteed. Every subset has a least upper bound. So you have a semilattice. And you can have a lowest element there. So you can have the empty state that is part of every other state. So you can interpret the partial order as a parthood relation, so ordering everything by parthood. And then at the bottom is the empty state that is part of every other state. You can then define fusion in terms of this partial order, right? If you just take the fusion of states to be their least upper bound, and you can write that as a square union kind of thing, right? That's fusion. Yeah, for the aficionados, you can notice already that this thing is a commutative monoid. And if you know phase semantics for linear logic, you might notice that the antiphases correspond to the possible states if you're into Girard kind phase space semantics. But if not, don't worry about it. This was really discovered by Dan Kaplan. I'm drawing on some of Dan's work. He has really worked out the similarity to the linear logic, and he's doing things a little bit differently. So he has nothing to do with the truth makers. That's all, as it were, my fault, bringing in the truth makers. The formal apparatus is pretty much all there in Dan's work, which I hope get published soon. So once we have all that on the table, we can talk about models, and we can let a model just be a modalized state space with an evaluation function on it. And the evaluation function now takes, so we take by what Fine calls bilateral propositions, and the bilateral propositions are such that they have truth makers and false makers, and those are subsets of all the states, right? Subset of all the things that makes things true and false. And evaluation function just assigns to every atomic sentence its truth makers and its false makers, and then we can extend that valuation by giving semantic clauses. Now we have to do that simultaneously for the truth makers and the false makers, so that we can get the semantic values, as it were, the valuation of all the complex sentences. Everything is just propositional, right? There won't be any quantifiers or anything like that in this talk. We're staying at the propositional level throughout. And the semantic clauses are just, well, something, an atomic sentence is made true by all its truth makers, false by all its false makers. And sorry, I should say the kind of forcing turnstile in the right direction is truth making, and backwards is false making. For example, the nec plus clause here says that a state S makes the negation of B true just in case it makes B false. And similarly, a state makes a negation false just in case it makes the negatum true. State makes a conjunction true just in case it's a fusion of parts, each of which makes one of the conjuncts true. And state makes a conjunction false if it makes either one of the conjuncts false, or it's a fusion of something that makes where each part makes one of the conjuncts false, and then dually for the disjunction. Fine usually puts some conditions on these models. And the first is downward closure. So if a state is possible, then all its parts are possible. Exclusivity, if you fuse a truth maker and a false maker of the same sentence, you get an impossible state. And exhaustivity, if you have a possible state, and you have a sentence, then you can fuse that possible state either with the truth maker or with the false maker of that sentence, and you remain possible. You still get a possible state back. I will occasionally talk about unconstrained state spaces, and by that I mean state spaces that where none of these conditions is imposed, right? As we're completely float free from any of that. And then occasionally I will talk about these constraints and what happens if you put them on state spaces. Propositions are fine. Let's propositions be just non-empty sets, or any subset actually of the states. And then if it's non-empty, then it's verifiable. And if it's closed under parthood, then it's closed. And a proposition is convex if there are two verifiers of the proposition, and one is a part of the other, then everything between it is also a verifier of that thing. That's convexity. And we can generalize that to bilateral propositions. I will always work with bilateral propositions. That means propositions that have truth makers and false makers. So you can think of the propositions as ordered pairs of truth makers and false makers. That gives you basically the whole setup of truth maker theory. Then the question is, if you're interested in logic, what is consequence? And now Fine tells you a lot of things, and he actually thinks that it's a virtue of his theory that there are several ways to define consequence. He has two ways of defining consequence that are that he often endorses. All these ways of defining consequence are somehow kind of preservation-like or parthood-like in spirit, I would say. So let me give you a couple of them. So entailment, there finds us that a proposition P entails a proposition Q just in case every verifier of a P is a verifier of Q. And then containment is proposition Q contains a proposition P if and only if two conditions. First, every verifier of Q includes as a part a verifier of P, and every verifier of P is included in a verifier of Q. There are other people who do things differently, and Fine himself occasionally does things differently. I mean, those are just for single premise inferences, right? So there's a question how you generalize it. One way to generalize is, for example, the way he does it with Iago. And there what we get is gamma implies A if in all models. If a state truth makes all of the premises, then a truth makes the conclusion. You can also have other ways of caching consequence out. In some papers, Fine says proposition P entails proposition Q just in case every state compatible with P is compatible with Q. That's actually a little bit similar to what I will do because it brings in possibility. Other people, like for example, Meyer, Punkochar and Sedler, do it a little bit differently. They loosen up in certain respects about the strictness or the exactness of truth making and say gamma implies A if and only if in all models. If there is a fusion of states such that each part verifies one of the premises, then that fusion includes as a part a truth maker for the conclusion. Now, what I want to get from this, what I want to show you is that it's just not clear what's the best way to define consequence in truth maker theory. You have options. You can think as Fine that it's actually a good thing that you have options, but you can also think, well, shouldn't there be a clearer way of doing this? All right, that brings us to normative bilateralism. So normative bilateralism. I guess at UConn, there isn't that much need to explain this, but so the basic idea of Restall Ripley style bilateralism is to have a broadly normative pragmatic account of logical consequence and one that can deal with multiple conclusions. And one way to say what they think, I think, is to say that gamma entails delta if and only if it is incoherent or out of bounds, as they sometimes like to say, normatively not to be done or whatever. In virtue of logical form, if you want to restrict to logical consequence, to assert all the members of gamma and deny all the members of delta. That's what it means to follow from. All right, this gives you a reading of the structural rules. So for example, reflexivity then becomes the idea that asserting and denying the same thing is incoherent or out of bounds. Weakening becomes the view that If you're incoherent, you can't repair that by asserting or denying more. If you have said enough to be incoherent, you have to retract. You can't do this by just adding stuff. And cut becomes the view that if a position is incoherent and you have a sentence, then you can extend that that position. So that collection of assertions and denials, called a position often by them, you can extend that position by either asserting or denying the sentence. All right, that's basically all I need from the normative bilateralism. Let me quickly talk about the different logics that I will occasionally talk about today. So it's ST, TS, LP, and K3. Then there will be a bunch of other ones that show up along the way, but those are the basic ones. So just for those not familiar with them, what you do is you have a three-valued logic, you have a strong cleaning scheme on them, and then you take fixed points, like Kripkean fixed points, for things to find truth values. And then the only difference, you do that for all of these logics, the only difference between them is what you take countermodels to be. In ST, so strict tolerant, you're strict with your premises, but loosen up, like tolerant with your conclusion. And then the counter model is something that is where all the premises are strictly true and all the conclusions are strictly false. So all the premises have 1, conclusions have 0. TS, you have all the counter model if all the premises are 1 or half and all the conclusions are half or 0. LP, if all the premises have 1 or 1/2. So 1/2 is tolerant truth, 1 is strict truth, and the conclusion is 0. And for K3, you have a counter model if all the premises are true and the conclusions are tolerantly true or false. So 1/2 is 0. So they're all closely related. And they're also all closely related to FDE, right? You get FDE, first degree entailment, from LP or K3 if you reject excluded middle or explosion, respectively, for the two, right? So for those that have it, right, can't reject, take away excluded middle from LP. Sorry, yeah, K3. Doesn't matter. I'm confusing myself. The one thing that is interesting to note is French and Ripley has shown that you can't have such a three-valued semantics if you reject weakening. And this is a very general fact. This has nothing to do with the semantic clauses, with the connectives. And they prove this in complete generality for any kind of valuation and inferences. This is, so you can't have anything like that if you want to reject weakening. On the proof theory side, for TS and ST, you can have a sequence calculus with Catalan style rules. And what you do then, if you just take the usual sequence calculus, if you want to have ST, you reject cut. And if you want to have TS, you have no initial sequence. And for all of them, you can have double line rules if you want to. For LP and K3, you have a kind of FDE-ish sequence calculus where, formulas never change side, right? They all stay on their sides, and then you have double negation things, and then you have kind of De Morgan rules for treating negated formulas on both sides, so that you don't have to change the side of any formula ever. So that's how these logics work. But this is not how I will treat them. So this is just that we're all on the same page what these logics are. Okay, now putting things together. What I want to do is just basically say that these two things say the same thing in a certain way, or that it can be mapped onto one another. One way to do that is to say, well, making true is kind of what the world does when it wants to assert something. And making false is what the world does when it wants to deny something. So this is where truth making is the worldly analog of assertion, and false making is the worldly analog of denying. And the incoherence of a position is the impossibility of a state. Now, if we take that on board, then we can immediately translate this normative bilateralism into truthmaker theory, and then that gets us, so I write this double turnstile with TM for truth making at the bottom. That's my truth making consequence. That's how I define consequence for truth makers. So this is the suggestion. This is the core suggestion of the talk. And it says that, so gamma truth maker implies delta if and only if in every model, if you want to have it for logical consequence. Any fusion of all the verifiers of the things in gamma and all the falsifiers of the things in delta, if you fuse them together, you get an impossible state. So truth making everything in gamma and false making everything in delta gets you an impossible state. I also have the empty state in there just in case if you let everything else be empty to be sure that you're left with the empty state. So that's why there's this empty state in the definition of it. And I define it in terms of conjunction and disjunction. That's unnecessary. It's just convenient. I could just have it be the fusion of the things, the truth makers of things in gamma and the fusion of false makers and things in delta. So there's no reliance here on logical vocabulary. It's just a convenient way for me to get this across quickly. All right, I hope that you see that this is just a copy, a metaphysical copy of the normative inferentialists, right? The normative bilateralists. I just translate everything and asserting into verifying, denying into falsifying, incoherence into impossibility. And then you get this pretty much straight out of the box, right? And I hope that this is actually plausible. I hope you see that this makes sense, because I mean, one way to see it is to think that what do we mean when we say that that an argument is valid? One thing to say is that the premises necessitate the conclusion. And one way to spell that out is that it's impossible for all the premises to be true and the conclusion to be false. And one way to say that is to say there is no possible state that makes all the premises true and the conclusion false, or all the conclusions false, if you have several of those. So that should be, I hope this is intuitive. That's my, well, I can't make it more intuitive than I did. So if it's not already, then sorry, but what's the hope? Now we can see what the structural principles then for that kind of consequence come to. And here, I hope that it starts to be boring. So I hope to bore you as much as possible in the sense that I think there's nothing new in a certain way on the table. Everything is just as plain sailing as it seems. Occasionally, we will come to more interesting things along the way, but the first thing to notice is that the structural rules are exactly the kind of conditions that Fine puts on his state spaces. You know, reflexivity becomes the principle of exclusivity, right? So if you have a truth maker and a false maker of the same sentence, you fuse them together, you get an impossible state. That's just reflexivity. Similarly, weakening becomes this principle of downward closure, right? If you have a state, and that is already impossible, then every superstate of it, but if you fuse it with more stuff, it stays impossible. That's just the converse of saying, if your state is possible and all of its parts are possible, right? So weakening is downward closure, and cut becomes this exclusivity principle, right? So what Fine says is that if you have a possible state, then, and you have a sentence, then you can always fuse it with either the truth maker or false maker for that sentence, and you stay possible. And that's of course exactly analogous to what people like Restall and Ripley say about cut, right? If you read cut from the contrapositively from the bottom up, then it means that if something doesn't follow, so if the position is coherent, then one of the premises is coherent. So you can either put the sentence on the left or the right and stay in bounds. And that's the same here, just with possibility. Just for completeness, contraction, how you get contraction, well, it's basically guaranteed by the idempotence of fusion, right? If you fuse something with itself, you just stay the same because you define it in terms of the least upper bound. And interchange, you get that by the commutativity of fusion, and that's also secured by it being defined in terms of the least upper bound. Which doesn't mean that you couldn't reject them, right? If you find another way of defining fusion and then reject idempotence or commutativity, then of course you can lose those properties if you want. All right, so let's look at the rules. Those were the structural principles. So now we have translated structural principles from truth maker talk into normative talk and back and forth, right? One-to-one. And you can do the same thing with the Catalan style double line rules. So I will use Catalan style rules, invertible rules, double line, so that I can infer back up and down. And then it's not so hard to see. If you think that the truthmaker semantics now is a semantics and yet your sequent calculus, and I write this funny side word Y for my sequent arrow here. I don't know. Figured out that that's what the cool kids do these days. So I thought I would do the same thing. So if you think of that as your proof theory, then you can, of course, wonder whether it's sounding complete. And you can do that, of course, for every rule if you want to. And surprise, surprise, it is. So one way to see this is to, so if you go for soundness, then you can say, well, what does the semantic clause tell you? Well, it tells you that the set of the truth makers of a negation is identical to the set of the false makers of the negatum. But if those are the same states, right? If these sets are identical, then if you fuse any member of that with anything that verifies all the stuff in gamma and falsifies all the stuff in delta, then it's either possible or impossible. And if it's impossible, then both sequence hold, and if it's possible, both sequence fail. So you never get a counterexample to the sequent rule in either direction. And for completeness, you can think of, well, what does the sequent rule tell you? Well, the sequent rule tells you that if you let gamma and delta be empty, then it just tells you any truth maker of not B is impossible, just in case every false maker of B is impossible. Sorry, there's a typo here. There should be the not B, the evaluation should have plus on top instead of minus. It's a truth maker, not a false maker. So the truth, the superscripts on the bars mean truth makers and false makers. If that's the case, then you can just think that for reductio, let the left-hand side, let the semantics fail. Then there must be a state that is a truth maker of one, and so, for example, a truth maker of not B and not a false maker of B, or the other way around. You let all the other states be impossible, that's that possible, then you have a counterexample to the sequent rule. That works in general. So this recipe works for all of the rules. I won't go through the other rules. It's the same. Maybe one thing that is a little bit interesting is that if you have a two children rule, right? So if the tree branches, what happens is that the states that are ruled impossible by the conclusion sequence is the union of the states ruled impossible by the two parent sequence. Also, on this slide, I do it without this third clause in the semantics. What this third clause is doing is it gets you contraction. So this third clause says that, for example, in this case, if you have this conjunction of B and C, false making the conjunction of B and C, it tells you that if something is a fusion of things, the first of it makes B true and the second of things makes B false and the second of things makes C false, then that's also a false maker. And that's the kind of stuff that gets you contraction. All right, this works for all of the rules. There's nothing really to see here. It's always the same. And what that means is that if we say that the state space is unconstrained, if we let all states, if we allow ourselves to distribute possibility over states arbitrarily, then these rules are sound and complete with respect to the truthmaker clauses, which means that they can do the same job as the truthmaker clauses, right? We have, as it were, we can use the Catalan style rules instead of the truthmaker clauses and get the same effect. Of course, if we then restrict the state space, what happens is that new inferences become valid because we throw away models. And then we would have to check whether they are still, whether we can derive them, right? Whether we still have the power in our sequent calculus to get them. All right, so Just to bring this together, if you put all these things together, we have for the state spaces that are constrained by exclusivity, exhaustivity, and downward closure, we have all the usual structural rules, right? Because we said that they translate into structural rules for sequent calculi. Our sequent rules are sounding complete with respect to the unconstrained state spaces. If we put those together, if we constrain the state spaces, because the structural properties are preserved by the Catalan rules, what you get is just classical logic. Right? Because if you put if you enforce all the structural rules on these Catalan rules to get classical logic, same thing happens here. So you have now a truth-maker semantics for classical logic. I won't bore you with the proof, just do brute first proof search on these things, and then you get the same result. There's nothing to see here. All right, now let's look at what you can do with this. Once you have that on the table, then it's again not so surprising what happens, because you know what the structural rules are, you know what the operational rules are, and then you know what you have to do if you want to get something. So if you want to get ST, you reject cut, right? And how do you reject cut in this truth-maker theory? Well, you reject exhaustivity. So you reject the claim that if you put together, if you have a possible state, you can always extend it with either truth-maker or false-maker of that state. If you do that, if you don't insist on that, then you get ST. And you get a truth-maker semantics for ST in this way. Defined in these terms of the truth-maker consequence. If you want to get TS, you reject reflexivity, and that means that you say it can happen that there is a truth-maker and a false-maker of the same sentence, you fuse them together, and you still have a possible state. That's your rejection of reflexivity. And you get TS in this way. And then you can also reject downward closure, and still everything works. So it's not like with the three-valued logics, so three-valued semantics, where you can't reject monotonicity. You can reject monotonicity and everything just stays the same for this. So let's run through it a little bit in more detail. So for TS, you can add a truth predicate, right? And for the truth rules, you can just have standard truth rules that give you a transparent truth predicate in ST. And you can immediately read off the truth-maker clauses for this, right? I mean, what these sequent rules tells you is that if a state is impossible if you add a truth-maker of A, then it's impossible if you add a truth-maker of truth of A. And if a state is impossible if you fuse it with a false maker of A, then it's also impossible if you fuse it with a false maker of true of A. And if you let otherwise the modal space be unconstrained, the only way to guarantee this is just to make them the same, right? To make them the same states. And that then means that what you get for truth making and false making is that the same states make A true and make true of A true, and the same states make A false and true of A false. And if you then allow yourself in a self-reference to define liar sentences and things like that, of course, in what happens in ST with truth is that cut fails, right? Because you get the liar and you get the incoherence of the liar, but you don't get the empty sequent. And the usual story about ST. And then you can now mirror this whole thing exactly in the truth-maker semantics. What you get is that a state makes the liar true just in case it makes, of course, it true that the liar is false. So it's not true. And by the false maker clauses, this means that the state makes the claim that the liar is true false. And that just is the same as making the liar false. So a state makes the liar true if and only if it makes it false. So every verifier of the liar is a falsifier of the liar. And if you think that any state that verifies the liar and therefore also falsifies the liar is impossible, then you keep reflexivity around, right? You let all these states be impossible, but cut will fail. I mean, that's you allowed yourself in this kind of way to reject this exhaustivity principle. We can prove that. Again, I think I won't bore you with the proof of this, but it's just that if you don't enforce exhaustivity, then and you have the liar around, so a truth predicate around in the way we defined it, then truth maker consequence becomes exactly STT consequence. The same works for TS. If you don't enforce exclusivity, you have a truth predicate around, then truth maker consequence becomes exactly TS with a truth predicate. Now it's a little bit boring to show this because these logics are empty, right? And they are empty at the inferential level. I mean, TS doesn't have a valid sequence. And so the easy way to prove that for the truth maker thing is just you let every state be possible, then you don't have any impossible states. And so you have no valid sequence, right? So it's a boring proof. But notice that on each side, the meta inferential level still holds, right? So our Ketenen style rules will still be sounding complete with respect to the truth maker stuff. So you get the same kind of meta inferential behavior in both of these logics again in the same way, even though they are both boring at the level of the theorems and at the level of the inferences, right? All right. And then what do we do with K3 and LP? Eduardo is around, so this is just Eduardo, but you know, in disguise, as it were. You just take what Eduardo did for ST and TS and then transfer everything to truthmaker. What you get is that LP becomes the logic of false makers, right? Because LP is, as it were, the logic, is the external logic. If you think of that as the external logic, as the logic of the theorems, then it's a logic for the stuff on the right, right? It's a logic for the stuff that lives on the right in the ST calculus. And those are where the falsity makers live, right? So you can then prove that schematically, if you close under substitution, what you get is that an inference is LP valid just in case. For every state, if you fuse that state with any of the false makers of anything in gamma, and you get something impossible, then if you fuse it with a fusion of all the false makers of delta, you also get something impossible. Another way of putting that is everything that is incompatible with the falsifiers of the premises separately is incompatible with any fusion of the false makers, the falsifiers of the conclusion in LP. So that's what the result that LP is the external logic of ST comes to once we translate into truth maker theory. And then, of course, we can do the same for K3. And there are two ways to get this, right? You can either switch sides by moving from ST to TS, and then you get K3. Or you can just not look at the right-hand side of your ST-ish sequence calculus, but on the left-hand side of your ST-ish sequence calculus, which amounts to the same thing. And then if you do that, if that's your way of thinking about K3, as it were, the external logic of ST on the left rather than on the right, then you see that it becomes the logic of verifiers, the logic of truth makers, right? You have the dual result. I mean, it's obvious. What I have on the slide is obvious once you realize that K3 and LP are duals of each other. So I swap the conditional around, right? I take and then instead of negating, I swap truth makers for false makers, or the other way around. And that just means that these two logics are duals of one another. So there's another way of saying that, as it were, I hope more intuitive way of saying this is to say that an inference is K3 valid means that everything compatible with some fusion of verifiers of the premises is compatible with some verifiers of some conclusion. All right. That is, as it were, moving from the ST-ish literature to the truth-making literature. So what I hope to have shown you is that once you think any of the solutions for for the paradoxes, for example, are plausibly treated by so going non-reflexive, going non-transitive, you can immediately transfer this to truthmaker theory, and you can keep the results, right? The results that LP is the external logic of ST on the right and K3 on the left and so forth all have analogues there. And these analogues all are fairly interesting, or at least, as interesting as the original result, I would think. Now let's try to go in the other direction from truth-making theory into ST-ish territory. One thing is that Correia has this logic of factual equivalence. And so what Correia is worried about is that, or is interested in, is having a logic that tells you when two sentences express the same facts about the world. And that's fairly fine-grained. So that's not just the same possible worlds or something like that. It's fairly fine-grained notion. And it is basically a version of Angel's logic for analytic entailment without distribution. So the difference between Angel's logic and Correia's logic lies in whether or not you have distribution around. And that Correia logic is the same as, so saying that two sentences are equivalent in Correia's logic is the same as that they play the same role as premises in ST. So if they play the same role, and I mean the same role without relying on the axioms and without relying on weakening. So just in virtue of the sequent rules, just in virtue of the operational rules. If you can prove that two sentences play the same inferential roles as premises, merely in virtue of the operational rules, then these two sentences are equivalent under Correia's logic. So since what Correia is tracking is sameness of truth makers, sameness of verifiers, that means what the truth maker theorist will say corresponds to these two sentences have the same verifiers. The bilateralist, the normative bilateralist will express by saying these two sentences play the same role as premises over all possible states, right? Over all modalized states, unconstrained modalized state spaces, just as the ST people will say over all base consequence relations, right? Over all initial sequence, all collections of initial sequence. This is another way to see that ST sequent rules and Fine's truthmaker clauses can do the same job. Now you can also recover Fine's notions of entailment and partial content, which is just his containment notion. So for entailment, for example, remember that Fine says proposition P entails proposition Q if and only if every verifier of P is a verifier of Q. And what you can show is that that holds between the proposition P and the proposition Q expressed by sentences with those names if in all models, if that holds in all models if there is an ST single line proof tree where there's a sequence that has P as a premise and then the root is the same sequence with Q as a premise. If you have something like that, then you have an entailment. That is easy to see once you realize that, if a premise state deems something impossible, that's the states that are deemed impossible by a premise sequence or a subset of the states deemed impossible by a conclusion sequence. Once you reflect on that fact, this result will start to seem obvious to you. For containment, or what Fine sometimes calls partial content, there's these two conditions, right? A proposition Q contains a proposition P if and only if every verifier of Q includes as a part a verifier of P, and every verifier of P is included as a part of a verifier of Q. And this can also be translated into ST-ish language by saying proposition Q entails proposition P if and only if the two sequence of the form, so P together with some theta, and the rest of the sequence is identical to Q replaced with the P together with theta. If those are interderivable just with double line rules, no reliance on axioms or weakening, then you get this containment. That's the same as saying that there's containment or partial content relation, according to Fine. This is, again, just depends on the same result, right? If you see that these double line rules ensure that there's the same truth makers for stuff on the left, then it's clear that these interderivability ensure that the truth makers for P fused with truth makers of the stuff in theta is the same as the truth maker of Q. And so it has to be the case that every truth maker of P is contained in a truth maker of Q, and every truth maker of Q contains a truth maker of P, because those are the same states. And once we have that on the table, we can mirror in ST everything that Fine does with his notion of partial content, right? Fine has a notion of partial truth around, and he does this, that, and the other thing with this. He has a notion of, so he gives us semantics for deontic modals in these terms, and then Moltmann has a whole semantics for modals in terms of truth-making, partial content things. So all of these things become available, as it were, from the ST perspective now, because we have reconstructed the basic building blocks of these theories within ST. Lastly, going non-monotonic. I said that you can go non-monotonic without any problem here, and I stand by my claim. So remember that that monotonicity is this closure, right? This downward closure. So possible states, all the parts of possible states are themselves possible. Now, if we give that up, we say that it can happen that a state is possible, but a substate of it, a part of it, is impossible. Or putting it differently, there can be an impossible state, and if you enlarge it, fuse it with something bigger, then you get a possible state again. So metaphysically speaking, what this means is that possibility can be restored by fusing with additional states. So you have an impossible state, and then you fuse with something new, and you get a possible state back. And normatively, this corresponds to saying that you can restore coherence by asserting or denying more. So you have asserted a bunch of things and denied a bunch of things, you're out of bounds. And if we reject monotonicity, it can happen that you assert more or deny more, and you're back in bounds. As I said, French and Ripley show that there's no tetravaluation or no trivaluation that can handle this kind of behavior. And of course, you can handle this behavior if you have standard non-monotonic logics on board, but notice that this will always require some extra machinery. So for example, in KLM, what you need is some partial order over all your models, or when you do linear logic and reject monotonicity like that, then you have this phase semantics, which I think people other than computer scientists usually don't really know what they should do with that kind of semantics. I mean, philosophically speaking, it's not so clear what you do with the phase semantics, right? Other than that, you have a semantics for your linear logic, which of course is great. But, and I think the truth-maker semantics has a much more kind of direct philosophical interpretation. Let me skip a little bit here. One thing we can do is we can still insist on exclusivity, right? So this is insisting on reflexivity in our sequent calculus. And we can even insist that all the impossibilities that result from fusing verifiers and falsifiers of the same sentence are downward closed, right? So that they are all monotonic. And what happens if you do that is that you get a supra-classical logic. So you include all of classical logic, but then you can just add more on top of that. Of course, that won't be closed under substitution, right? Because classical logic is post-complete. I mean, what do you expect? For example, what this would come to then is that you could say, look, the state of the match being struck and the match failing to ignite, the fusion of these, that's an impossible state. But the fusion of the match being struck, the match being wet, and the match failing to ignite, that's a possible state. That's fine. And that all works it's plain sailing with this truth maker theory. Now the weakening and reflexivity are preserved by the Kettinen rules, and then we have to insist on contraction, right? And we can get contraction in certain ways. We have to fiddle around a little bit to get it if we don't enforce it in special ways. But one thing that I want to highlight is that you will lose weakening in this way. You will lose cut in this way. So if you lose weakening, this will bring with it failures of cut in the following way. Imagine that you want to lose weakening for A entails C, and B is a diffeser for that inference. you can immediately see if you also insist on reflexivity and these reflexivities being closed under monotonicity, then you get this this monotonicity for this A to C inference here. You might think you don't want to lose cut, but I think, so first of all, we are already in a STICH landscape, so we have, as it were, cut is in the rearview mirror a long time ago, but this holds again here, even in the substantive part, not just in the paradoxy part, because the idea is that fusing a truth maker of B with a truth maker of A and a false maker of C restores or heals the impossibility, right? That is the whole idea. And once you buy into this idea, this failure of cut won't look implausible to you anymore. I mean, if it still looks implausible, I think what happens is that you haven't gone really on board with the initial idea that this can happen, that you can heal impossibilities in this way. Then lastly, you might wonder, well, what about math and logic? I like transitive and fully structural reasoning, monotonicity. I like all these things. How do I get those? Why can I reason like this in these fields? And of course, the answer is kind of just, well, in these fields, the truth maker and falsity makers do obey all these principles, right? The possible states are closed under exhaustivity, exclusivity, and downward closure. And because they are possibilities in these fields are closed in this way, you can reason classically in all of these fields. All right, almost done. Let's wrap up. Under this truth maker bilateralism, as I call it, so this is the translation of normative bilateralism into truth maker theory. We can see that Fine's truth maker clauses are equivalent to the double line Kettenen rules. And the constraints on possible states correspond to structural rules. And now once we have this, ideas can travel freely from one side to the other, because we always know how to mirror everything on the other side, right? If you reject a structural rule, then this has a direct correspondence, direct translation in the truth maker theory, for example. Truth maker theorists can now use ST-like ideas to solve paradoxes, like, for example, rejecting cut, or if they want to go TS-like and reject transitivity, that's also in the cards in the usual way. And they have views on LP and K3 as the logic of truth makers, logic of false makers. Normative bilateralists can avail themselves of all these notions of factual equivalence, partial content, and all the other things that Fine and analytic metaphysicians are throwing around in the literature, right? You can just copy that and give them a kind of thin or normative, I don't know thin, but another interpretation. And we can reject monotonicity if we want, and nothing, there's just more rejection of principles for possible states. Thank you.